Okay, now we're going to look at how to convert moles to grams of a molecule. So read the question and try to figure out which is your given and which is your wanted. All right, so in this question, we have 200 moles of ammonia. And just so you know, ammonia is this chemical right there. It's that molecule right there. It wants to know how many grams of ammonia is in 200 moles of ammonia. So our given, of course, is the value that they gave us. They gave us 200 moles of ammonia. And what is ammonia again? What molecule is it? It's this one right here. It's NH3. I'm going to put that over 1. And what about our wanted? Our wanted is grams of ammonia. They want to know how many grams of ammonia is in 200 moles of ammonia. So once again, let's look at our units that we have here. We're given moles of ammonia, and we want grams of ammonia. So obviously we don't have the units, we're not given the units that we want. So what do we have to do? We have to cancel out these given units and get our wanted units. So let's cancel out the given units. Where am I going to put it in these two boxes? Am I going to put it in the top or in the bottom? I have to put it diagonal so they can cancel out. So I'm going to put it in the bottom. So there's my moles of NH3. Okay. Now what can I put in the top box here? Okay, back to this. So what can I put in my top box? I can put up here grams of NH3. Okay, and once again, what do we have in these boxes right here? We have grams per mole. And what is grams per mole? Grams per mole is molar mass. Okay, now ammonia, this molecule right here, NH3, it's a combination of elements. So I can't just look up NH3 in the periodic table. Instead, what I have to do to figure out the molar mass for NH3 is I need to use this little system that we've talked about previously when we did molar mass. Element subscript times molar mass equals the total molar mass. So let's look at what we have for NH3. What elements do we have for NH3? We have N, and we have H. What is our subscript for N? Now notice NH3, the N doesn't have a subscript, which means that it's a 1. So the subscript for N is 1. What about the subscript for H? That subscript is right here, right next to the H on the bottom right. So H subscript is 3. Multiply. What is the molar mass for nitrogen, for N? You got to get that from your periodic table. So you go on your periodic table, you find nitrogen, and nitrogen is right over here. And you notice the number at the bottom is your 14, that's your molar mass. So nitrogen's molar mass is 14 grams per mole. And you do the same thing for hydrogen. Hydrogen is over here, and hydrogen's molar mass down here is 1. So that's 1 gram per mole. Put our equal sign here. Now let's do our first problem. Let's do the nitrogen. So 1 times 14 is 14. 3, and then hydrogen. 3 times 1 is 3. And what do we do with these two numbers? We add them. So what's 14 plus 3? That's 17. And our units are grams of NH3 per mole of NH3. So our molar mass of ammonia, NH3. So it's 17 grams per mole. I go back to my problem over here. What's my molar mass for ammonia? It's 17 grams per mole, per 1 mole. Okay. Now that we canceled out our units, the moles of NH3, we canceled them out here. We're left with our grams of NH3, which is what we're looking for, our units. We filled in our numbers, so all we have to do now is multiply across the top. 200 times 17, 200 times 17, 3,400. Now across the bottom, 1 times 1 is 1. So 3,400 grams of NH3 over 1. And your final answer is this, 3,400 grams of NH3. So if I have 200 moles of ammonia, that's the same thing as me saying I have 3,400 grams of ammonia. Right? So now what you're going to do is you're going to do this problem here. Work it out on your own. Now notice I brought back our good friend, scientific notation. So whenever you plug this into your calculator, whenever you need to use that number, I would recommend every time you write scientific notation, put that number in parentheses. So start with your parentheses, you put your 2.3, you put a times multiplied, you put a 10, and then there's usually a little exponent button, and it looks like this, kind of like a triangle pointing upward. That's your exponent, and then you put your exponent number, which is 6, and then you close parentheses. Okay? So that's, if you're going to type that number in your calculator, I would recommend typing it like that, in parentheses. Okay? You have another option. You can actually write this number out in standard form. So if you remember how to do that, put your 2.3, okay? And I'm going to move my decimal 6 places. Since it's a positive exponent, I'm going to move it 6 places to the right. So 1, 2, 3, 4, 5, 6. I fill in my zeros here. Okay, and then underneath I can just rewrite my number, 2, 3, and there's 5 zeros. 1, 2, 3, 4, 5. So this number right here is the same as this number up here. So if you want, you could type it into the calculator like this also, if you want to do it that way. But ultimately, I would just recommend writing it out in scientific notation. And if you get any answers that are really big in your calculator, I would recommend writing those answers in scientific notation. That helps me out a lot. It makes it a lot easier for me to grade when you do that. Okay? So do your work, and your final answer should be 1012, 1, 2, 3, 4, 5 zeros. Okay, and this is going to be grams CO2. Okay, so this is going to be your final answer. Right, so work out your problem. So that's what you get as your final answer. Now what I want you to do, lastly, is I want you to turn this into scientific notation. Okay, so turn this number into scientific notation. All right, and if you get a big number like this as one of your answers in the assignment, write it out in scientific notation, because it makes it a lot easier for me to see if you got the answer correct. Okay, so go ahead and once you get your answer, give it a try. I'm going to write it out in scientific notation right now, but I would rather you do it first on your own, just to make sure you kind of know how to do it. Okay, so how would you write this number in scientific notation? Well, you start with the first number you see, which is a 1. After the first number, you put your decimal, and then you look at the numbers after that. If it's nothing but zeros, you can stop right there. But notice there's a few numbers still lingering here that aren't zeros. So I got to keep going until I hit those numbers. So there's this 1 point, and there's a 0 right after the 1, and then there's a 1, and then there's a 2, And after that 2, there's pure 0, so I can stop right there. Now I'm going to put my times 10. Now I got to see how many, what my exponent's going to be. So my new decimal is now in between the 1 and the 0. Okay. And I got to count to where the old decimal was, which is at the end of this number. So how many spaces is that? 1, 2, 3, 4, 5, 6, 7, 8. So that's my exponent. And of course my units are still grams of CO2. Okay, so make sure you get that answer. And the reason I say that is because in these problems here, you're going to see that when you're converting from moles to grams, some of these problems are in scientific notation. The numbers are in scientific notation. Okay, so go ahead and answer those questions, and then I have some extra credit questions at the bottom. Give these a try, guys. I'm very curious to see if you can actually get these answers. Okay, enjoy.